What we're talking about today is called direct variation. We're going to do two things. One's going to be called direct, one's going to be called indirect. Indirect will be probably in a chapter or so. Direct variation, you're going to write an equation. So your goal today is to write an equation. All your equations will end up looking like this. Y equals a number times x. So, a bunch of examples. It could be y equals 2x, y equals x, y equals negative 1/2 x, y equals 6x, y equals negative 9x. In all cases, there's going to be a number in front of the x, and that number in front of the x is called the constant. It's the multiplier. Maybe you get a job and you make $6 for every time you shovel a person's sidewalk. So your function is y equals 6x. You want to make more money? You shovel what? More sidewalks. Every time you shovel, you make 6. All right? So that's just an example of direct variation. And our goal today is to understand and how to find what's called the constant of variation. And that variable is always called k. All right? We say this, y varies directly as x. So when it's written y equals a number times x, that means y varies directly as x. It's just a way to talk about that. So, two things we want to try to figure out. How do we determine if it's direct variation, and if so, what's the constant? Really simple. All right? Let's look down here at our first examples. We'll come back up here to these steps to follow in a sec. If the equation is in the form y equals a number times x, it's direct variation. So let's look at this. Is this y equals a number times x? Yeah. So that is direct variation. Is this y equals a number times x? Nope. What about this one? Yep. Okay. Here, is that y equals a number times x? Why not, Brett? Yeah, because of the minus 7, so it's not. What about this last one? Y equals a number times x. Once again, it's not because there's no x. So we go back to the ones that we said yes on, and let's just write down what the constant is. Here, k equals 4. Here, k equals negative 3. So it has to be exactly y equals a number times x. And so there's going to be a question on the test that says, is this direct variation? John, if it just says y equals a number times x, it is. Now be careful. The special case is y equals x, in which case k equals 1. If it's anything other than those first one and third one, it's not direct variation. So, just a summary, it's got to look like that. All right, and the k is the number in front. So, moving down. Example 2. Let's say we have a problem, and this is written in what's called standard form. You don't need to remember that, but you're going to see that word again, and I just want to mention it right now. So, if it's written in this form, we want to try to take this equation and put it in y equals mode. So how do I take 4x plus 3y equals 0 and get the 3y, first of all, by itself? How do you get rid of this positive 4x? Brett? All right, so put a minus 4x underneath. That gives you 3y equals negative 4x. I'm not quite to y equals x yet. How do I get rid of the 3 in front of the y? Okay, so divide by 3. So take each one and divide by 3. That gives you the equation y equals negative 4/3 x. Nate, you need a pencil? Do you have your notes? Okay, you need to take them out. All right, so our value of k is negative 4/3. And this is direct variation. So we have kind of two things. Number one, is it an example of direct variation? The answer is yes. And if so, what's the constant? The constant is negative 4/3. Really straightforward. All right, look down at example 3. Same thing. Is the equation an example of direct variation? So let's do the same process. How do I get the 4y by itself? Justin, start me off. How do I get rid of this negative 2x? Okay, so add 2x to both sides. 4y equals 2x plus 7. So I'll translate that up to here. Next step. Jalon, I'm going to do to get rid of the 4? Okay, so divide all 3 by 4. That gives me y equals 1/2 x plus 7/4. And now you have to analyze. Is this an example of y equals k times x and that's it? Luis is saying no. Why not, Luis? Give me the reason why. Okay, there's that extra plus 7/4. Good. So this is, to answer the question, is this an example of direct variation? No. And put a little note to yourself. Because of the plus 7/4. That's the reason why. Okay, so that's not an example of direct variation.